All right, so let's get started. Sorry again for the delay. So today we're going to, for those who I haven't introduced myself yet, my name is Tian. I'm a PhD student from Prashant's lab. And today I'm going to give a guest lecture about data centers and cloud computing. So if you haven't seen me before, and this is 377, so just in case you're wondering, you're in a wrong classroom. All right, so let's get right started. So cloud computing and data centers. So let's first talk about data centers. And in today's lecture, I'm going to talk about a little bit about data centers. A lot of you who probably already heard of these terms. What is data center? And later on, we're going to switch into talking about one of the very popular OS technologies that used in today's data centers called virtualizations. It allows data centers to run in very large scales with very economic scales. The third one, I'm going to talk about the introduction to the cloud computing, which focus on their Amazon EC2. I'm going to show you a little demos about how to use EC2. I think Prashant's going to give a lab about that, if I'm not wrong. All right, so data center. What is data center? So data center is, correct? Yeah. Anyway, so data center is actually contains a large collection of servers with storage farms, potentially thousands of, millions, not millions, tens of thousands of servers, and they can potentially have computing resources that can serve users from all over the world with all the data you probably put into a Dropbox or whatever. They all hosted in one of the data centers somewhere. All right, when it first started, data centers mostly used by enterprises for running their server applications that serve users. So as you can imagine that most of the big companies, that Facebook's, Google's, Microsoft, you name it, they all have their data centers built somewhere. One of the reasons that they're using data centers to run applications is because they have users from all over the world. They need to give the fast access to every user who are using their services. And also, as I mentioned before, data centers give them this very nice scalability that can actually easy to manage and save them a lot of money. So as it is used by their large companies, it's also data centers is fairly common to use for data processing. If you have, say, if you want to, say, in the warehouse that has a lot of data to process for their customers, they want to find out what the customer is interested in. Then in the back end, they will run their data analysis tools to say, okay, hey, if I see this user buying this product, and then, well, what is the chance that other people that were also interested in the product, and what product are we going to actually get in stock so people can actually, buy from us? So this is type of data processing that usually run also in data centers because the computing powers that the data center provided. And also, of course, websites, business apps, and that requires a lot of resources to run. So one of the concrete example of data center apps that I would really like to talk about is Netflix. Although this is not what you're thinking, but as you were using Netflix, I'm sure most of you have used it before, and to watch one of your favorite TV shows, titles, whatever, when you first put on Netflix, and then people are just watching at the same time. And Netflix actually were hosted in data centers in the very beginning of its business, and then they have to service all this user requests come thousands of millions or maybe tens of thousands of users simultaneously access one of the TV shows, right? So they have to actually stream your requests from stream your requests from all these data centers that can actually give you a good service. All right, I don't know, this is not synced. All right, so enough about the basic data center. So let's talk about what is inside a data center. So as you can see from the picture on the right, it is a very typical data center pictures with all the racks of servers, storage arrays, network switches, and the lighting you see that's actually very cool is like, light up, and actually went into one of the data center we're going to talk about in the next slides. This is super cool with all those lights. So the rack of servers provide all their computing powers that the data center need to sustain all the users, and the storage arrays and just hold all your data that user put there, or applications, logs are there, and then network switch is of course used to interconnect all their servers together, as they cannot just functioning as a standalone machines. They have to be interconnected with each other in order for this distributed setting to work. All right, so, and also besides all this, essential, like basic equipments inside the data centers, there are other things that actually required for data centers to function. All right, the first one is the cooling infrastructure, which is really important. If you think about having thousands or tens of thousands of machines in a very condensed area, one problem that comes to your mind is that all the heat all the heat the servers are going to generate. All right, so without the cooling, the data center basically just going to be toasted. So cooling is very important, and one very interesting fact to remember is that for every dollars of computing resources the data center is providing, it actually needs another dollars to actually cool it down. So cooling is actually very important. All right, so of course there are power converters, power up the servers, and also power up all the cooling infrastructures, AC and such. And backup generators is also very important for providing their high availability inside a data center. Think about when their power is off, and how when data centers just power off, all their applications running inside just suddenly don't work. But it seldom happens, is maybe very few times every few years. So this is due to they have really nice design of high availability based on how they actually manage the data centers. All right, so as I mentioned that data centers is very important. They actually build around the world. There are a lot of data centers, and actually we have we have one that is really close. This one is in Holyoke. All right, so this NGHPCC actually stands for the Massachusetts Green High Performance Computing Center. Yes. So this data center is actually a data center that is dedicated to the research users in Massachusetts. And UMass is actually one of the 5 founding schools of these data centers. And Prashant and some of his students did a lot of work in this data center to make it energy efficient. That's where the green comes in. So as you can see, the white containers on the left and the right, in the bottom left and right, they're actually the cooling devices inside the data centers. And the middle pictures on the bottom is actually the server racks that just used to stack servers inside. As you can see, the first picture is what data center looks outside. This particular data center looks from outside, and it looks very small compared to the data centers owned by Google and Amazon, but it's a very good size one. And it is said that it's used $80 million to just build this facility. Not to mention that you have to put servers inside. So let's talk about this. So why do we set up this data centers in Holyoke? Based on what I said earlier, what actually make people want to set up data center in Holyoke? if it's for Massachusetts, why don't we set it in Boston? Why? Yeah, that's a good one because all right.
There's a big uplink in New York that's easier to connect to.
Yes, that would contribute to.
There's like canals and waterways there, so they can actually make their own power that they're using in the HPCC.
Yes, correct. So yeah. So anyone want to put more thoughts on that? Oh, okay. So yeah, these three answers are all very good. So first of all, as I said, this data center is for Massachusetts use mostly. So for a central location like Holyoke, actually I don't know whether it's so central, but it's a good guess. So for a central location, whatever it is, and it actually can provide a little, very low network latency for all the users in Massachusetts, which everyone can benefit from. If you put it in the far north or south, and people in the center or the other side would not have the benefits. And the other one is saying that it has fast internet connections to one of the major uplinks. That's correct. You want your data centers to be able to actually, not just isolate it somewhere and then have to make a lot of network round trip to actually just get to anywhere. But that's a good one too. So the energy one is actually, I think, one of the reasons is actually Holyoke data center is chosen. It's one of the most important ones. So because Holyoke is cheap, the realistic is cheap because they have this facility there. If you want to build this in Boston, it's going to cost you not just $80 million. I don't even want to guess how much it is. So and the hydroelectricity power, whatever, is generated by their the water there is used actually to power this data centers. This data center is actually it's a very small one, but it still requires like 10 megawatts electricity to run, I believe. And then just think about, typical desktop or servers requires like 1 kilowatt, 1 kilowatt to run, and then you just think how many servers is potentially going to be there. Oh, just a side topics. As I said, this Holyoke data centers cost $80 million. Do anyone know that how much brew will cost to build? All right, nobody. $19 million. Just a fun fact to share with you guys. You know that Brew is rebuilt, right? Okay. All right, so yeah, so let's just look at this modular data centers. It's another approach to build the data centers. As I mentioned, that data centers could be very expensive to design, build, and architect. And one way people think about it is that how are you going to fastly put up a data center that can just be used immediately. So, well, you just, like everything else, you just put it into, you just pre-made it, and then you ship it, and then once you buy it, you get it, you just plug in, and then everything is supposed to be manually working. All you need to do is just plug in. That's what this idea of modular data centers actually is about. All right, no questions. Great. So before talking about the last piece of data centers, I just want to quickly mention that the data centers built today are mostly modern data centers. They're very dynamic. They can scale really well, and they can actually have the flash mappings from the virtual to physical servers, which we're going to talk about in the virtualization technologies. So the dynamics is enabled by the dynamics is enabled by the virtualization technologies. Sorry, and then the large scale is actually comes from the automations that employed in the data centers runnings. Think about if you have to manually, as a system admin, you have to manually manage like tens of thousands of servers all by yourself. It doesn't go anywhere, So, and then the traditional one, as you can conject yourself, is static and then has need a lot of manual works. All right, so when I talk about data centers, we're going to look at some of the challenges that data centers today faces. The first part is the resource management. There are so many resources, servers, storage, and networks, and even cooling you need to manage. So the one question comes to mind is that how are you going to efficiently use all these resources you already packed in? All right, so think about not all the servers might be needed at exact same time. Some of them might still be on, but there's nothing running on that. And those servers are potentially idle, and for saving purposes, you probably want to automatically turn it off when there's nothing running on that to just save you a couple bucks, right? But for the other hand, if you turn it off automatically, the other benefit is that it's not going to generate heat, and then you don't need the cooling to cool this bit of resources, correct? So also for nowadays the applications become more distributed, and a lot of for popular applications there are a lot of users like Facebook, and I'm sure every one of you just use Facebook all the days. And then people might set Facebook at different times. For example, if you're in the class, you're probably not checking your Facebook, and I hope you're not checking your Facebook. And your friends probably don't have class at this time. They're just checking Facebook and doing all this on Twitter and such. All right, so all these applications will have the variable, and the workload will vary based on different usage behaviors. And on the other hand, as you think about like during their Thanksgiving seasons, which is coming up soon, and people were just suddenly, well, it's not unpredictable, but you definitely cannot predict how much shopping people are going to do online. So it's one, or maybe a better example of unpredictable workloads would just be like some outbreak news and you don't know, and then suddenly everyone is so interested in this, and then just swarm all this in one particular service. So how do you actually manage your resources to enable all these apps with all this variable and predictable workload to function well, even with the workload changing? And the other hand is that the low cost effect is actually very important. So data centers, as they turn out to be a very, very successful business model to run the cloud computing. So they actually want to keep their costs low so that they can actually benefit from renting service out to customers who are actually using it. So yeah, and then the automatic resource management and performance profiling. Yeah, performance profiling actually comes into providing all this nice performance and guarantees for their applications. So, okay, in energy efficiency, we have already talked about it, and servers, consume a lot of energy. Well, just a fun fact to share is that Google actually owns a lot of data centers. And do anyone of you want to guess how many electricity Google data centers actually use every year? All the electricity consumed in the world? Just a wild guess? Nobody?
Okay. I redact my guess that hasn't been made yet, but it's got to be in the gigawatts.
Percentage is fine. Just what percentage do you think?
What percentage?
Right, yeah. 9%? A quarter of the world electricity? Oh wow! So yeah, that's Close, yeah. So actually, one of the things that Google is actually bragging about is that their data center is very energy efficient. They said they only use less than 0.01% of electricity on the world. All right, but think about this is the world electricity they're talking about, and Google as a company is using 0.01%. Is a lot already, but still they're doing a very good job. The other fact that I'm going to talk about is that the saving Google is talking about is actually coming from that they're using renewable energies from I believe it is the wind farms that close to their data centers. It's 35% of their energy actually are from the wind farms. So just think about it. The rest. All right, so I promise this is the last couple slides of data centers and we're going to switch something cooler than this. All right, so as I said before, data centers can be really costly, and just this figure you just need to just keep in mind is that the thing I said, $1 of computer resources roughly equal to $1 of electricity that consumed to keep this data center up and running. All right, last one. Okay, economy of scale. So with this in mind, data center actually can be used to build into this cloud. Yeah, that service a lot of that can be turned into a business model that can potentially provide they have very low costs and then they rent their resources to you with relatively low costs, so everyone wants to rent from them and then they can make the money out of that. This is done by just the automation techniques, virtualization techniques, and all right. So let's just switch to talk about the virtualizations for now. So virtualization in a simple word, it is actually a separation of the service that you can request. But this service is actually decoupled from the underlying physical resources that deliver this service, which might be a little tricky to understand. But so I just want to give you several examples of virtualization and you can think about it. So the first one, my favorite one is the video game emulator. All right, so most of you probably know that you can play whatever, Super Mario World in your Nintendo console, but you can also play that on your PC. Through what? Through a video game emulator. And how does it achieve that? It basically just emulate the PC as a Nintendo game controller, so that your game that's originally designed for the for the Nintendo can actually play on their PC. So it is type of virtualization. All right, so you see that the service, which is you playing a game, is decoupled from the actual physical resources that deliver service, which now is PC, not Nintendo. All right, and the second type of virtualization is actually it's actually application level virtualization. One of the examples I want to give is very popular. Very popular one is Wine. It's called Wine. So for those who don't know, Wine stands for Wine is not an emulator. So it is not an emulator. So what it does is actually it enables you to run Windows applications on various machines that supports POSIX. I don't know how to pronounce that. Just this is type of you can just think of it as the next machines. So basically, you can just play your favorite games of time, like League of Legends on your Ubuntu machines and such. And I don't know how good the performance is, but accordingly, the claim performance is pretty good. But I'm sure every serious gamer has their own PC. But this is just something that you can try out. All right. So, but today we're not going to talk about all this. We're going to talk mainly about the virtual machine virtualization for machine. All right, so to achieve the virtualization of this particular type of virtualization, we need to consider three parts that actually, that actually make possible the CPU, memory, and I/O virtualization. All right. Before jumping into the CPU virtualization, I just want to quickly share with you some very interesting facts about what happens in virtualization world. The first virtualization project actually starts in their IBM Cambridge research centers. That's supposedly the project they're building is trying to build a virtual time sharing memory time sharing OS that's to enable their time sharing requirements. As you know, that the machines at that time is super big, and then they need to actually, collaborate to actually work on the machine to coordinate. So they want to have this time sharing feature of that. And then later on in 1999, the virtual VMware, some of you might already heard of it, is found a patterns about the supposedly first virtual platform that you can use to run different operating systems on their existing operating systems. Alright, my favorite part comes into the end. Is in 2003, it's a project from academia. It's from the University of Cambridge. They have this cool idea to open source this virtualization platforms to enable people who are doing research in this field to be able to advance this technology furthermore. And then the first professional open source one, which is supposedly was come out in 2007, VirtualBox. And I don't know how many of you have used it before, but for those who, okay, good. So for those who have not used it before, I just want to show you the quick demo of what it actually means. And hopefully, those of you who have used it before, and then this mouse is not coming. All right, where's my mouse? Here it is. All right, so this is actually a VirtualBox's software that's running in my Mac. You can see inside there is two pre-installed virtual machines that actually runs Ubuntu. All right, so it's actually super fast. I'm just going to click on that, and then it's not working. Click on that, and then what it does is it's going to grab the Ubuntu machine I pre-installed in this image and just run it on my Mac. And as you can see, that is coming up very fast, I presume. Well, considering my Mac is really powerful, so it is pretty fast. All right, so once you have this, all right, so this is actually a full functioning Ubuntu machine. It's not something that you just it doesn't do anything. It just looks like Ubuntu. No, it's not. It's an Ubuntu machine, and it has all those features about Ubuntu that you can use. And that's just is very. All right, so this is a demonstration. All right, so you guys cannot see it. I don't know how to make it work. I just want to show you the machine is not working. I want to show you the process, and then I cannot just drag it. That's so weird. Okay. All right, so let's just close this virtual machine first so I can show you something else. Oh, what time is it? All right. When is this class at? 9:45, I believe? Okay. All right, so we're not out of time yet, which is good. And let's see, how are we going to... Oh my God, no. Let's just shut it down. And maybe we shouldn't show you that. I just, this is a little tricky, and because it was showing different screens, I just want to minimize it and show you the process that's running. As it turned out, I can't, but it doesn't matter. It's not important. The fact is that I want to show you that there's actually a separate process that starts when this virtual machine starts, and you can see it from your activity monitor or whatever you choose to see. All right. So after saying that, so we're going to talk about the CPU virtualization. There are basically 3 different types of virtualization that is utilized in CPU virtualization. The first one is the full virtualization, which full virtualization actually just, as you can see from the figure, is the user applications are run unmodified, and they are whatever their instructions are made directly to their hardware that's actually run. They actually run on that. But the guest OS, which is the one that I just started earlier, the Ubuntu, the instruction is made to their hardware resources by doing the binary translations on the fly. I don't know whether it's on the fly, probably not on the fly, but they're just translating this to the underlying OS instructions using their VM, which stands for their virtual machine monitor. All right. So one thing to take away here is that this type of virtualization is very fast. It doesn't require any operating system levels modification, which means when I started Ubuntu machine earlier, when I pre-installed it, I didn't change anything about the Ubuntu machine. I just grabbed it online, and download it, and then just hit start install, and then I just magically install it on the VirtualBox. So VirtualBox is a type of for virtualization. All right. The second part is the parallel virtualization. From the name, it says pretty much about it. It is not technically a full virtualization, as you can see. What it does is that it actually requires OS level changes of the machine. Supposedly, I'm running my Ubuntu machine. That I want to run an Ubuntu machine using this technology. All right. What I need to do is I need to make some changes to the kernel to make it actually work with the virtualization level that is employing this technology. So one thing to take away is that then is a parallel virtualization. It requires some level of kernel changes, but don't panic. You don't need to do that. People who are been doing it has already put up a lot of patches to your kernel. You can just patch it, or they even have pre-made images you can just use. But it does require some work of other people to make this type of virtualization work. All right, so this type of virtualization, it actually needs to virtualize the process memories and guest OS to virtualize IOs. This is the same thing with other stuff. So the last one is the recent one. Is called hardware assisted virtualization. So if you think about it, you can change operating system, the kernel inside a particular OS to make this work. Why can't you just change the hardware? Because why it doesn't come out first? To start, the hardware assisted virtualization come out the latest. There's reasons about it, because it's not easy to just design the instructions on the chips. And industry like Intel and AMD, they actually started doing that quite a while ago, but they managed to finish it in around, I believe, 2006. It's first virtualization, hardware virtualization actually employed in their chips, and you can buy machines. All the machines purchased after 2006, I believe, has this capability of doing hardware assisted virtualization. So this type of virtualization is really nice. For the recent generation, it can actually achieve very, very nice native speeds with running a virtual machine using the technologies. It doesn't require OS changes, or it does is that the company already did the hardware changes for you to enable this type of virtualization. All right. So after CPU virtualization, you also need to virtualize the memory for the machine to actually run, for the Ubuntu to actually run on my Mac. All right, because from Ubuntu's point of view, it actually runs on the machine, the physical machine itself, and then it sees all the memory sees, and you want to grab it all and use it. So the idea is that it's very similar to whatever the current operating system is doing, is having a level of mapping between the physical and the virtual memory. All right, so the physical memory seen by the Ubuntu is actually also a virtual memory. This virtual memory is managed by the virtualization layer, the monitor, to make it work, to do these two levels mapping to actually translate it into the machine memory. All right. One thing to take away is that you just need to remember is it did a mapping itself in their virtualization layer. Okay, so device I/O virtualization is also very important. It's the last part of the virtualization to enable you to run the virtual machine. All right, so everything needs to be. It has to make the 1 to C's I/O keyboards, network cards, and such. Enable in order for it to get the internet. You can actually type in it, and then it's just not like a box that you have it running. So that's one challenge of the device I/O is that you want to keep the CPU overhead low, because without that, it's just not working. All right. So by having the CPU memory and I/O virtualizations, we can finally achieve the virtualization that we're able to run the virtual machine. This kind of virtualization allows us to run multiple virtual machines in a single servers, very powerful servers. The idea you want to do this is, again, economy, and you want to maximize the utilization of your servers so that you actually get the money. You have the goods. Your money is actually worth it. So the example will be that if you previously have this, it's not correct. Let's go back. So the example will be that if you previously have Windows and Linux machines running without virtualizations of 2 different machines, and now you got another powerful machine on the top with the virtualization layer installed. And what you can potentially do is that instead of running 2 machines, you can run them both on top of that powerful machines. So you have the Windows and Ubuntu on the same machine. So that just makes it easy to manage, I believe. 1 is always better than 2, I guess. Also, the very cool stuff that virtualization enables you to do is it actually decouples the virtual machine from the physical resources as mentioned before. And with that, you can actually do is that if you say, okay, my virtual machine that runs Ubuntu actually needs to be scaled up because there are so many requests just coming into the service that is running on this particular machine. And you can just take the virtual machine and easily command, like migrate it to a different server. It's actually bigger than the one that you previously run on it, which is really nice. It enables you to dynamically configure and scale up your virtual machine. So, well, I guess the VirtualBox I want. Yeah, maybe I should. So the VirtualBox is one you can actually also configure whatever the resource you're assigned to your virtual machine. And I'm not going to give a demo about it. And it's very, very simple. You just open up the preference and you can do it. So yeah, so this is the 4 very popular virtualization tools that you can use to achieve this whatever we're doing over there. So with the virtualization in data centers, and you can what you can achieve is that the benefits will be consolidated servers, as we showed before. That you put you can buy two physical servers and buy a big one and put the virtual machine on top of the big servers to ease the management. And you can easily, by doing this, you can say, okay, you have a savage machine, you can just have 10 machines if you have a very powerful one. But there's definitely disadvantage of doing that. So you need to think about it very carefully. So the other use case of the virtualization will be the virtual desktops, which virtual desktop potentially is allows you to run your you don't necessarily run it yourself. So it allows you to have virtual machines in their data centers. And you're going to access it with a very simple client, which runs on the protocol that both of them agree with. All your clients do it, so all the heavy lifting works are done in their virtual machine inside the data center. All your sync client is doing is just going to pull the updates. It's basically doing screen updates only. It's going to pull the updates from the data centers, the virtual machine running in data centers, and display whatever it is available from there. So the benefits of doing this is that, think about it as the enterprise settings. Enterprise can actually use them as settings. They can save money because they just don't need to buy the very same client. The client is very cheap, and you use it. All the machines are in a central location. They can easily manage with all the security and benefits of doing batch software updates and management and monitor your virtual machines and such. And also, of course, you don't need to carry around very heavy machines. And although nowadays the machines not that heavy anymore, the desktop, using this, you can potentially have more than one desktops in the data centers, and it's available for them everywhere. One very high-profile example of this will be the service of OnLive. Not sure whether you guys have heard of it before. OnLive actually is a service that is implemented this idea, but instead it allows you to work, that allows you to play games that they installed and buy and then hosted in the cloud. All you need to do is you don't need to have a very powerful PC to play the games. That's supposedly to be played on a powerful PC. All you need to do is to pay a subscription fee to OnLive, and then they can give you their access to all the games you want. You can just play it from your not as powerful machine. All right. So with all that, we're going to jump to talk about the clouds. I'm going to just quickly talk about it, and we're going to show you a demo of how to host your favorite PaaS features websites on their application. All right. So what is clouds? All these companies are very high-profile company that offers cloud services. So they're different, but they all share 4 very common characteristics in order for them to be providing this cloud service. So cloud has to be remotely accessible. All right. So in order for them to be cloud, it's not hosting somewhere very close by. Although their Hollywood is close by, but it's not that close by. You still need to use SSH or whatever to remotely access it. All right. And the second very important feature of cloud is that it provides the pay-as-you-go service, which makes that you only pay for whatever you're using. You do not pay upfront fees to buy the servers, although there's type of instance you actually can do that. But in general, you pay whatever resources you use, and it's usually charged an hourly. And the high scalability comes from that they actually design their centers in a way that they can actually easily scale up whatever virtual machines running on their physical machines. They purchase more physical machines. So more virtual machines there. It has very flexible mappings between the virtual machine and physical machines. And of course, they all this virtual machine running on their shared infrastructures with one another. Oh, there is 3 types of clouds. The software as a service cloud is hosted. The example will be the service that Google is providing. The Salesforce is a database service cloud that provides you access to databases that you can just dump the data in, get the data out, don't need to worry about how fast the database is running, and how much resources you actually need to assign to the database. They take care of all for you. All you need to do is dump in, dump out. All right. So platform as a service is actually very interesting. One of the very famous example will be Google App Engine. I don't know how many of you have used it before, but essentially this type of service led you to use the API provided by Google and write the languages in that API that it provides, and then you deploy your application on their platforms. They're going to handle all their scalability, the resource manager for you, and if the user resource comes, there's more user resource comes in to your applications, they're going to scale it up for you. And it provides very easy management. And all you need to do as a developer is you just need to write a code based on that API and hand the code to them, and they take care of the rest for you. All right, it sounds really simple, right? I think they previously only supported Python and Java, and now they also support PHP and Go, which is very wide because these two languages are getting really, really popular to build distributed web service. All right, the last one is infrastructure as a service. That's our favorite topic. That's about Amazon EC2. All right, so infrastructure as a service, you can actually rent the raw resources from the provider and do whatever you want with it. All right, today we're going to show you how to start a website for your cat on Amazon EC2. All right, so we're running out of time, so the rest are not that important. We're just going to see this demo. All right. Okay, can you guys see it really clearly? Whatever is displayed. Actually, let me just jump back. Okay, so one thing you have to, where is my mouse? Okay, one thing you have to know is that in Amazon, it provides a very nice feature for those of you who have used the SSH before, or command line 2 before. Provides very nice things about letting you access their resources easily. And the first thing we're going to do is that you have to find the image, the pre-installed images you use to start your instance, right? So, which the image is just like saying Ubuntu. Right, I'm just going to run it on Amazon. So first thing, I'm going to find an image. I made the image myself. So oh no, we don't have internet here, do we? We're not. Okay. So what does this say here? Unable to blah, which means I don't have internet connected yet. Oh, I didn't even think about that because we usually do it in. Great. That's a big boomer. Great. Oh no. UMass edu-ROM. Oh well, apparently my edu-ROM doesn't work. That is so good. Okay, great. This is not working. Oh, I really, really want to show you guys this because. Well, apparently we can go online. This is really frustrating, but I'm sure we can figure it out. We are computer scientists, right? So. Oh man, this is not. Yeah, apparently it has the internet. That is so weird. Okay. Unable to execute. All right, great. This is not working. Oh man, and we're running out of time too, so. All right, let's just skip this then. Let's just finish the lecture or whatever, and we're going to get off. All right, so I already talked about the Google App Engine. And, one thing to take away is that it doesn't need virtualization, and all it does that is that you use the threads just to spawn more threads on servers to actually sustain your application's growth. That thing is not everyone wants to host their applications on the public clouds because all this concerns about security and privacy issues. So the idea is that, but they also want to take advantages of whatever the economies that the public clouds is providing, the pay-as-you-go service. So one idea people come up with that is that they use the private clouds to actually compensate this fact that the data hosted there is not secure. So what they do is that they host all their critical applications or data in the private clouds, which basically is the cloud inside their enterprises. These tend to be really small data centers, maybe just hundreds of servers in a room inside their enterprise. What it does is that they can achieve the benefits of both the world. That by using the private cloud, they can have easy control of the security of all their access from the internet. And also they can scale up their applications by just using the public resources to run the non-critical type of application and service. So this is the ideas of the hybrid cloud. All right, last one, cloud challenges. And as mentioned, that the potential challenge will be the privacy and security issues. Think about your applications running on in somebody else's home, so you don't have any control of that. So one way to do it is you have to really one thing that the cloud provider is actually doing is that they are trying to make it really they're trying to make the virtual machine, this kind of boxes, really secure by providing by using a lot of rules to interpret the network package that comes in and just filter out whatever the package they think is described. The second and third challenges we already talked about. So it's just how are you going to manage all these tens of thousands of servers that actually runs in a cloud, and in terms of energies and maintenance of the machines. Not like if you install once and then it's good for all. You have to actually update it, keep updating it, and keep managing it, and keep monitoring. All right, we're done with this. So let's figure out how to run the demo. Great. So I don't know why this is not working. Did any one of you have Ethereum set up? This.
You just have to go on the browser and log in before you can actually.
Okay. Well, apparently I can ping from my whatever terminal, but it just doesn't work when I do the EC2 command. That is so weird. Let's see. I cannot see anything. Okay, let's Just try whether it works. Oh, great. Connect. This is the thing you have to connect. Oh my God, where is it? Let me just, let's just do this here first. Make it work, and then we can. Sorry about this. Yeah. All right, cool. We got it. Okay, we still have less than 10 minutes. Let's. All right. Oh, okay. So let's do this. Blah. All right. Bear with me with all this nonsense that is happening today. All right. Let's not get distracted by the background pictures here. And now there's who's that? I don't know. Anyway. Yeah, we figured it out. So the first step of trying to host something on Amazon is that you need to have the image, which is the machine image that pre-installed with the operating system. That my case is Ubuntu. I already pre-installed it, so we're just going to grab the image that I pre-installed. I'm going to start it. This is so silly. Okay, we know. Okay, so it's very nice. It's one command. You say, okay, we're going to run this instance with the key. My key is Tien, okay, and we're going to run it using a image, which is this image ID. You can. There's a lot of publicly available pre-made image from Ubuntu or even Amazon. A lot of company has made it. So I just grabbed one of those images I made myself, and I'm going to run it with what type. So the type is basically whatever, how powerful your machine is going to be, okay? So I'm going to run it in this super, super small micro instance because it's free, all right? All right, so we're going to run it. And it has to return the real result. They say, if you can see in the second line, it says, okay, pending, which means they're trying to create it. It's not up and running yet. All right, so what we're going to do is that we're going to, so describe instance. All right, so how do you know when the instance is actually up and running? All right, so you need to check so that you can SSH into that. We're just going to check, okay, which means describe instance, describe the status of the instance, which I just start, which the number is the I/something is just the instance ID that Amazon assigned to their instance. All right, so as you can see, still pending. Okay, we just wait a couple seconds, and then we do it again. And we do it again if it doesn't work. And we do it again. It's still pending. And sometimes when it takes a long time to actually start a very small instance because so many people are using free resources in Amazon and just run out of the small instance. If it doesn't work, we try a bigger one with money, so it doesn't really matter. So, all right, still pending. Okay, but as you can see, it's already assigning one of the public IP address starts the fourth column in the first row. EC2 blah compute Amazon. This is basically the IP disaster that's assigned to this instance. Once the pending status changes to running, I can actually, okay, yeah, it's running. So you can actually SSH into this. Okay, so let's go ahead and then, okay, so we're gonna copy this IP address and then why it's not? Okay, copy this IP address. And we're going to say, okay, hey, we're going to SSH into this. And basically, as you probably know, it's using a public-private key pairs. And I already have those configured. And for the security, I'm not going to show you the keys. So basically, it's for most Ubuntu instance, first log into the Ubuntu at this particular IP address is assigned to you, and you say, okay, hey, I want to add it, and then yes, I want to log into it. And just wait, and then you can log into it very soon. All right, so now we get inside one of the machine that is running actually in Amazon. This station is actually in Virginia, so this machine is in Virginia. So what we can do is we can say, all right, so this is my local machine. This is the Amazon machine, and you can see the ping time is about around 16 milliseconds, I guess. So it's very close. All right, so this is the machine that's running in Virginia. It's not local, all right? So what we're going to do is we're going to start a web server, the Tomcat, Apache, whatever. Okay, so go inside this. Well, you can use whatever web servers you want. So we start it up, and then it is up and running, and then we're going to see whether it's actually running or not in the browser. Browser, where are you? Browser. Okay, browser. One thing that I don't really like about this is it's so inconvenient to switch between windows, and I don't know how to do it. Okay. I don't even know whether it's going to work, but this is the fun part. It's just a couple minutes. All right, yay! So this is the web browser, and then you're going to have this website set up already. And okay, saying this is your first website, and what you want to do is that you want to have this nice picture. You want to host a website for your cat. All right, so what are we going to do is that we're going to use rsync. For those who don't know what rsync is, it's actually just copies your image from locally to whatever the Ubuntu, copyright, the remote server, which the picture of Muffin is a cat, which cat is called Muffin, of course. So this is my cat. Oh my god. I don't really want to type all this, but just bear me for 2 seconds and you're going to see this nice website about my cat up and running. Alright, so hopefully it copies the image. So I just copy the image into one of the whatever directory that actually hosts that particular website I show you. So there's Muffin's pictures up and running, and then we're going to go inside this. We're going to change one of the picture to Muffin's picture. Well, if you just haven't know how to do this, you probably should make a copy of this, but for time's sake, we're not going to make a copy of that. Yeah, so exciting moment comes, and then this Apache cat is going to be a Muffin's picture, and you're sort of like, okay, so you have your cat's pictures outlined, and all you need to do is just take all this and then change whatever HTML file you actually use. Okay, so I think we are okay. One very last things. So this is whatever it's up and running, and last thing we're going to do is that since it's already up and running, we know how to do it. Last thing, very important. If it is using your own money, you need to terminate this instance you just start. All right. So we're going to quickly do it. We're still going to check the status of the instance to grab the ID of their instance, which we say, okay, the running one is having this instance. All you need to do is just terminate it, so Amazon's not going to charge you any money. Great, it says shutting down. Okay, the moment it's shut down, it doesn't charge you any money anymore. All right, one last thing I want to mention before we end this is that Amazon actually have this free tier stuff that you can try out. And it's in the slides, and you can check it out yourself. You can go there, assign your account, and then you can use the resources provided for like a year for free and try this out yourself if you're interested. All right, so we are out of time, so I guess the class is over. Thanks so much for your attention today, and I hope you enjoy this class. All right, thanks.